Good morning, children. Chapter 5, Introduction to Euclid's Geometry. This lesson takes you back to the history of geometry, that is, how it was originated and what all developments happened so that the current geometrical concepts what we are using, how it has taken shape. That is a description of the mathematicians who have worked on it and the development on geometry to reach this stage. The introduction part, it is a Greek word as geo and metrain, which shows that geo means earth and metrain represents to measure. That is, geometry has originated for the purpose of measuring land. You can see the detailed explanation in the textbook when the need of the Nile river overflowing, the different boundary of the land has to be marked again and again every time when the natural disasters occur. So, basically geometry originated for the purpose of measuring land. This branch of mathematics took various forms in every civilization: Egyptian, Babylonian, China, India and Greece. You can see the role of geometry in the building structures or in the road constructions in those civilizations, which means that the geometrical concepts were used in almost all ancient civilization. But it was being developed and used everywhere, but there was no scientific approach. The only way of passing on the idea was either through orally or simple messages. It is at that time the Greek mathematician Thales first developed a known proof that a circle will be divided into two equal parts through a diameter. His favorite student Pythagoras and his friends took the role and many properties are developed in theory of geometry in his time. Euclid collected, the next mathematician, Euclid collected all the known work from all these mathematicians, and he, by adding his own contributions, he made a book called Elements, and he divided these elements into 13 chapters, and each chapter has been made as a book. This is the origin of geometry, and the definitions, the axioms or postulates made by Euclid will be highlighted in this lesson. He took all the materials available and he is the one who has compiled it and making more changes brought about the field of geometry to this stage. In Euclid's time, the Greek mathematicians during his time, they considered geometry as the world around them. They understood that a solid occupies space. It can be moved from one place to another place, and it has a surface either plane or curved, and these surfaces will coincide at lines or curves, and these lines will reduce to points. So this was the notion during that time. That is, from the solids have 3 dimensions. Then the surface of the solid will be plane or curved, like solids like a cuboid will have plane and a cylinder will have curve. It has come to a 2 dimension. Then the edges of the cuboid can be a straight line, and the edge of a cylindrical can be a curve which has only 1 dimension, and the edges meeting at a point, that is, it has no dimension. So this was the geometrical notion at that time, and based on these geometrical notions, some definitions were made by Euclid at that time. The first definition is, a point is that which has no part. A line is breadthless length. The line has, the ends of a line are points. How much you reduce the length, how much you reduce the line, there will be a bit of length, and so this idea is also a bit abstract. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface are lines. A plane surface is a surface which has evenly with the straight lines on itself. So all the definitions at that time could not clearly convey the meaning. So the mathematicians at that time accepted the concept of point, line, plane as undefined terms. That is, they were not defining these concept of point, line and plane. After these definitions, Euclid assumed certain properties, and these properties were actually universal truth. That is, they don't need a proof for it. That means it was an accepted fact. So these accepted facts Euclid divided as either axioms or postulates. The meaning of axiom is what all accepted fact or universal truth can be applied in all branches of mathematics. That is, the axioms can be applied in all branch of mathematics. That is, arithmetic can be used in arithmetic, algebra, then measures or measurement in all branch of mathematics, and the special name was given for the accepted facts in geometry as postulates. Specifically when we are using certain facts in geometry, he called them as postulates, but later on we started axioms for geometry too. So the axioms what I am going to explain is the way Euclid has developed during his time. So when you read the statements clearly, you will understand currently where are we using those axioms. These were the 7 axioms by Euclid, that is the accepted fact from that times, and when I explain where are we using it now, you will understand that very clearly, and any 2 or 3 axioms you will have to learn because it may be asked for the exam. See the first axiom. Axiom means it's an accepted fact or a universal truth. So things which are equal to the same thing are equal to each other. Very easily you will understand if A and B are equal and B and C are equal, then automatically A and C are equal. This is the concept. This we can apply in case area of a triangle and area of a rectangle are equal. Area of a rectangle is equal to area of square, which shows that area of triangle is equal to area of square. Or the addition of 6 plus 4 is 10, 7 plus 3 also 10, which shows that 6 plus 4 is equal to 7 plus 3. So we used this logic in all branches of mathematics. If equals are added to equals, the wholes are equal. The same way, 6 plus 4 and 7 plus 3 are equal. As we said now, if 1 is added to both sides, again the whole of 6 plus 4 plus 1 is 11, 7 plus 3 plus 1 is 11 is not getting disturbed. That is the meaning. If equals are added to equals, actually we are doing this for algebra. If you want to add 1 on both sides or subtract 1 on both sides, when an equation is given to you, you can apply this axioms, you were applying this axiom. If equals are subtracted from equals, the remainders are equal. If equals are added to equals, the wholes are equal. The next, things which coincide with one another are equal to one another. You can take this in the congruence. How can you prove two triangles are congruent? When you superimpose one triangle on the other, all parts of one triangle exactly coincides. Then we used to say that the triangles are congruent. So this is the axiom under consideration. That is, things which coincide with one another are equal to one another. The whole is greater than a part. It's very well understood. You have a bottle, 1 liter bottle with full water filled with 1 liter bottle with water up to 1 liter. You are removing a part of this water and pouring into another bottle. You can see that the whole is always greater than the part of the water collected here. Or this concept we have used in fractions. A fraction is a part of a whole. That means when you take a small part from it which is equally divided, it's called a fraction. So the concept whole is greater than a part we have applied in fractions. Things which are double of the same thing are equal to one another. Things which are double of the same thing. In case you are given x and y are equal, automatically 2x and 2y are also equal. Similarly, if two quantities x and y are equal, half of x and half of y are also equal. This we have applied even in geometry. X plus y plus z is equal to 180. That is angles and property of a triangle. What will be half of each terms, half of x plus half of y plus half of z will give you half of 180, which is the same as 90 degree. So things which are double of the same thing are equal to one another. Things which are halves of the same thing are equal to one another. So these were the axioms developed at that time, which currently also we are using in every branch of mathematics. Please study 3 or 4 axioms as is may be asked for the exams. There are 5 postulates. As you know, the universal truth meant for only geometry. The first postulate is there can be only one line which can be drawn from one point to another point. That is, you are given 2 points A and B. Through A, infinite number of lines can be drawn. Through B also, as many lines possible can be drawn. But if you want to connect A and B using a line, there is one and only one line which is possible to connect or which will contain both the points. So the first postulate is a straight line may be drawn from any one point to any other point. That means a straight line may be drawn from any one point to any other point. If 2 points are given and if you want a line passing through both the points, there is only one line possible. That is the first postulate, postulate 1. The second one, a terminated line can be produced indefinitely. What is the meaning of a terminated line is you have a line and it is stopped at 2 points A and B. This is the meaning of a terminated line, or in short the line segment we are calling now. The postulate is a terminated line can be extended on both the sides infinitely. This was postulate 2. The third postulate is a circle can be drawn with any center and any radius. That means if you fix a point and you take a fixed distance, if there is a fixed point and if there is a fixed measure or radius we call it, we can draw circle which shows that with any center and any radius we can draw circle. The logic is a circle can be drawn with any center and any radius. You need only a fixed point and a fixed length, which can be anywhere. All right angles are equal to one another. All right angles. That means if you draw a right angle, like this, or if you have 2 lines perpendicular, or if you have a rectangle, if you have a square, the angles formed all you can see as perpendicular, and so the measure is 90 degree, which proves that all right angles, the name is right angle, and in whatever figure they appear, they are all equal to one another. Then all these 4 postulates, please copy in the notebook, and it was very easy to explain and it is easy to study, and please study the postulates. The fifth one is an important one, mostly for the exams they are asking. After my explanation, the statement will be easy for you. The fifth postulate, part by part, I will explain with the figure. If a straight line falling on two straight lines, first you draw two straight lines A and B. If a straight line falling on two straight line means it is falling on the straight line, and what is this straight line making is make the interior angles on the same side of it taken together as less than 180 degree. You can see here the angles here, if you total it, the total of this angles will be less than 180 degree. That is, if a straight line only on this part you can see it will be more because this is already an obtuse angle. So, if a straight line falling on two straight lines, and if that line is making interior angles on the same side of the line less than 180 degree, now what is the logic is, let us produce these two lines, this line in this direction, this line in this direction, this line in this direction, let it be straight, and this line here in this direction. What is happening is, let me make it straight, the remaining part, then the two straight lines, if produced, I produced the straight lines, what is happening? Meet on the same side of which the sum of the angle is less than 180 degree. They are proving that this side, however far you extend the lines, there is no chance of the line meeting, whereas this part will definitely converge to a point. This postulate is very important. Please study the statement as in the textbook. It is an important statement. You can give the explanation too in the same way with the figure illustration.